Myself, Dr.N.Ram Babu. I was working as an assistant professor in the Department of Electronics Engineering at the University-Surampalem. In this session, we are going to discuss about two-port networks, and in detail we are discussing on ABCD and hybrid parameters. ABCD is also known as transmission line parameters, and the other line for hybrid parameters is H parameters. So, in both the parameters, we will be discussing in detail. Now, coming to the outcomes, we are going to analyze concepts of ABCD and hybrid parameters in two-port networks. Coming to the transmission line parameters or ABCD parameters, it is given by equation V1 is equal to AV2 plus BA2, whereas I1 equal to CV2 minus DA2. Here also it is minus. Okay. Therefore, we observe these equations means where V1 and I1 are, V1 is input voltage and I1 is input current, whereas V2 is output voltage and I2 is output current. So, in order to attain the equations of ABCD parameters, at first instant I am taking I2 is equal to 0. If I assume I2 is equal to 0, we can get the values of A and C. A is equal to V1 by V2. Okay, that means this I2, that means the secondary side voltage is open circuited. In a similar case for C, it will be I1 by V2. Okay. Now, in order to get the equations of B and D, V2 should be kept 0. For V2 should be kept 0 in the sense B is equal to V1 by minus I2. At that case, V2 is short circuited condition. In a similar manner, D is equal to minus of I1 by I2. Okay. Therefore, if you observe, this means A is in terms of voltage, V is in terms of mho, and B is in terms of impedance, and D is in terms of current. Now, let us go in detail. Now, in the given circuit, that means if we take a simple series and parallel R1 R2 circuit, for this circuit, we need to find out the ABCD parameter values. So, for that, here I am simply writing the KVL equations. If I observe this one means V1 is equal to I1 R1 plus R2 into I1 plus I2. Therefore, I1 into R1 plus R2 plus I2 R2. We got this expression. Now, I am writing the KVL equation for the secondary loop. So, V2 is equal to, the only one is resistance and both the currents are entering, therefore, I1 plus I2. Therefore, I1 R2 plus I2 R2 is the KVL equation for the secondary loop. Now, from this, I am going to obtain the parameters in two different methods. First parameter is direct substitution method and the second method is with the help of KCL KVL equations. So, first I will be going by first method. So, these are the equations which we have written it over here. So, in order to attain the value of A, I need to substitute this I2 equal to 0 in equation 1. If I substitute I2 equal to 0, then it will be V1 by V2 is equal to R1 plus R2 by R2. This one we got it. Now, B. For attaining B, V2 should be equal to 0. If I substitute V2 equal to 0, then this one is R2 I1 plus R2 I2 equal to 0, right? Therefore, R2 R2 will get cancelled. Therefore, it will be I1 is equal to minus of I2 and I1 by minus I2 is equal to 1. That means, we got the expression for D. Another V2 equal to 0, right? We need to substitute it, and for that if I substitute V2 equal to 0, then we will be getting V1 by minus of I2. For V1 by minus of I2 is R1. Okay, this one we got it. I2 equal to 0. If I substitute I2 equal to 0 in equation 1 or equation 2, let us substitute in equation 2. If I substitute I2 equal to 0, it will be V2 by I1 is equal to R2. Therefore, I1 by V2 is equal to 1 by R2, this one. Therefore, like this, we can get the solution by method 1, or else we need to apply the KCL and KVL methods. Now, let us solve that equation also. I am using this as equation 1 and this as equation 2. Now, let us write the ABCD parameter equations. V1 is equal to AV2 minus BI2 and I1 equal to CV2 minus DI2. This is equation 3. And this is equation 4. Now, take equation 1 and equation 3. In equation 1, V1, I1, I2 is there, but in equation 3, V1, V2, I2 is there. So, this is not suitable. Now, let us go for equation 2 and 4. V2, I1, I2. Okay. Now, in equation 4, I1 is there, V2 is there and I2 is there. Now, compare equation 2 and 4. Okay. Now, I am rearranging equation 2 in terms of 4. Okay. V2 is equal to R2, I1 plus R2, I2. R2 I1 is equal to minus V2 plus R2 I2 and I1 is equal to minus V2 by R2 plus I2. Therefore, I1 equal to minus V2 by R2 plus I2. Now I am keeping it as 5. Now by comparing equation 4 and 5, comparison C equal to minus 1 by R2 and D equal to minus 1. See, D1 we got it, 1 by R2 also we got it. Now, whatever the value of I1 that I got it, I am substituting this value in equation 1. Okay, V1 is equal to R1 plus R2 into I1 minus V2 by R2 plus I2 plus R2 I2, that is R1 plus R2 minus V2 plus I2 R2 by R2 plus R2 into I2. Now, if you solve this one means, okay, minus R1 V2 minus R2 V2 plus I2 R1 R2 plus I2 R2 square plus R2 I2. So, if you observe this one means, here it is V1, V2, I2 and I2, V1, I1 and I2. So, if you compare this one and this 3, you will be getting the values of A and V which are equal to this expression which we got it. So, in this manner, we need to get the ABCD equations for this method. Okay. Now, let us move on to hybrid parameters. So, the equations for hybrid parameters is given by V1 equal to H11 I1 plus H12 V2 and I2 equal to H2 I1 plus H22 V2. So, now here now to get the values of I1 or H11, I need to substitute V2 equal to 0. If I substitute V2 equal to 0, I will be getting the values of H11 and H21. That means a second side port 2 is open short circuited. In a similar manner, in order to get the values of H12 and H22, I1 should be equal to 0. I1 should be equal to 0 in the sense the primary side is open circuited. Okay. Now, let us write the equations of H11. So, H11 when V2 equal to 0 is V1 by V2, input is units are ohms and H21 is I2 by I1. Okay, this is the current again, amperes will be the units and H12 is equal to V1 by V2, okay, it will be voltage and H21 is equal to I1 by 2, during this time I1 equal to 0, it is admittance, that means mho, okay. Now, let us go draw the equivalent circuit diagram. V1 is the voltage source, right? So, V1 equal to H11 I1 plus H12 V2, it is a dependent source, whereas I2, here I2 is the current source, okay, I2 is equal to H21 I1 plus H22 V2. So, this is the equivalent circuit diagram and here what are the units we have discussed stated over here. Next, for the simple circuit, that means the previous problem only, we are going to derive the equations of H parameters. So, I have taken the same example. So, therefore, the V1, V2, the KCL equations will be same. Now, from these equations only we need to derive the equations of H parameters. So, here also both the methods, first method is similar to that V1, V2 parameters and the second one is KCL and KVL equation method. I am going for KCL, KVL equations method. So, these are the equations which I got it over there. I am renaming it as equation 1 and 2. Now, let us write the equations of hybrid parameters, that is V1 equal to H11 I1 plus H12 V2 and I2 equal to H21 I1 plus H22 V2. This is equation 3 and this is equation 4. Now, let us compare equation 1 and equation 3. Equation 1 is in the form of V1 I1 I2 and equation 3 is V1 I1 V2. So, both comparisons not possible. Now, let us go for equation 2 and 4. V2 I2 I1 I2 V2 I1 I2. So, observe this means equation 2 and 4 resembles same. Therefore, now I am converting equation 2 in terms of 4. V2 is equal to R2 times of I1 plus R2 times of I2. Therefore, R2 times of I2 is equal to R2 times of I1 minus V2. Therefore, I2 is equal to R2 by R2 1 minus 1 by R2 V2. Therefore, now compare equation 5 and 4, you will be getting H21 is equal to 1 and H22 is equal to minus 1 by R2. Now, we need to calculate the values of H12 and H11. For this, we need to substitute this I2 value in equation 1. Therefore, it will be C. Equation 1 is V1, I1 and I2. If I substitute this I2 value in equation 1, you will be getting I1 and V2. I1, I2 is I1 comma V2. Okay. Now, see I1, okay, I1 comma V2, V1. So, if you observe this one, let it be expression 6 and equation 3, V1, I1 and V2. Okay. So, from compare equation 3 and 6, from here you will be getting the values of H11 and H12. Okay. So, in this manner, we need to calculate the values of H parameter equations from a given circuit using KCL and KVL equations. So, From this session, we have calculated the values of ABCD transition line parameters with a simple problem, and also we have calculated the hybrid parameters, that is H11, H12, H21 and H11 using first conventional method and the second one loop transformation techniques method. Okay, thank you.